Hello students, in previous lecture we have studied about the Surds. The Surds, which is new concept to this year to all of you. That is, all of you have studied about that nth root of a, if that nth root of a is irrational number, then nth root of a is known as surd. And for example, there are few examples of surd is given here, that is root 3, root 2, root 5, cube root of 9, fourth root of 25, seventh root of 10. These are the examples of surds, as well as 2 root 5, root 2 into root 3 are also few examples of that surds. And surd can be written in two different forms, that is mixed surd and simplest form of surd. For example, see here, root 40, which is one of the example of surd, which is in the form of mixed surd. Then that root 40, it can be converted into simplest form. See here, it can be converted into simplest form. Then here root 40 means 8 into 5 as well as 4 into 10. Therefore, this can be written like that. Here root 4 into root 10, and therefore here root 4 means here 2 root 10. Then see here 2 root 10 is the simplest form of surd, and the generalization of that simplest form of surd can be written in the form of p nth root of a, whereas see here that is the simplest form of surd. Then see here there are few operations which is related with the surd. Today I am going to discuss with you the few operations takes place on the surd. Then in previous lecture we have studied about the similar surds or like surds. Those concepts are used or it is useful in the operations when takes place on the surds, like addition of surd, subtraction of surd, multiplication of surd, as well as division of surd. And one more thing, that is we can compare the surds, few basic concepts which is related with the surds, that is simplest form of surd or like surds or similar surds. That concepts are also useful to compare between surds. Let us consider if A and B are real numbers. If those two numbers are real numbers, any real numbers, then there are two possibilities, that is if A and B, those are, it may be rational number, or A and B, it may be surds. Then see here, if A and B are any real number, then there are total 3 possibilities when we compare between those two numbers. Then we have to compare, that is comparison between real numbers as well as the comparison between surds. Then if A and B are any real number, it may be rational number or it may be surds. Then see here, there are three possibilities between A and B. That is first possibility, that is if A is less than B. Let's see here, A is less than B. Then if A is less than B, then we can write A square is less than B square. As well as see here, the second possibility, that is A is greater than B, then we can write A square greater than B square. And third one possibility, that is A is equals to B, then A square is equals to B square. These three possibilities are lies between A and B if there are any real numbers. Taking examples of those real numbers, we can compare or we can prove those properties. See here, for example, see here, if here A is less than B, that means here 3 is less than 5, then 3 square is less than 5 square. That means here 9 is less than 25. Similarly, the second one property, if here A is greater than B, that means here 7 is greater than 3, then here 7 square, that is 49, is greater than 3 square, that is 9. That means here 7 square is greater than 3 square. As well as the third property, that is A is equals to B. That means if those two numbers are equal, then 5 square is equals to 5 square. That is here 25 is equals to 25. Then see here, we can prove the few properties which is related with the surd by taking examples of it. Then let us solve few examples which is based on the comparison of, that is comparison of between surds, comparison between surds. Then see here, if A and B are surds, then we can compare between two different surds. For example, see here, 7 root 2 is one of the surd and 5 root 3 is another surd is given here. Then we can compare between these two. Then see here, first of all, those surds we have to convert it into mixed surd. That means, see here, 7 means it is a root 49. 7 means it is a root 49. And as there is no any sign is there, therefore there should be multiplication is between 7 and root 2 is there. Therefore into root 2. Similarly, see here, 5 that should be written like this, that is root 25 into here root 3 is there. Then we have to multiply that root 49 by root 2. Therefore we get root 98, and here root 25 into root 3, that is root 75. Then see here, it is now in the form of mixed surd. Then we can compare between those two surds, because here the nth root, that is of A, that is here n is equals to, in those surds n is equals to 2 and here radicands are different. When we can compare in those surds when their order are same. Here order of both those surds is 2. Now we can compare between those two surds and those surds should be written in the mixed form. Then we can compare between those two. Therefore here 98 is greater than 75. Therefore here root 98 is greater than root 75. And here see, here root 98 means here 7 root 2 is greater than root 75 means 5 root 3. Then one more example I am going to discuss with you, that is see here second one example. 4 root 7 and 9 root 2. Then see here we have to convert this simplest form of surd into mixed form of surd. Then convert it into mixed form. Therefore root 4 means root 16 into root 7 and 9 means it is a root 81 into root 2. Then see here root 16 into 7, isn't it? And root 81 into 2. Then see here we have to write the multiplication of 16 into 7, that is 112. And here 81 into 2, that is 2 8 are 16, 162. Therefore see here, therefore root 112 is less than root 162, and here root 112 means it is a 4 root 7 is less than here 9 root 2. That is the comparison between two surds. Then we can take one more example for comparison between surds. That is here 7 and 2 root 5. Those numbers are given there. Here 7 is a rational number and 2 root 5 is a surd. We can compare between here, that is rational number, as well as in surd. Then 7 means here root 49 and 2, that means root 4 into root 5. Then see here root 49 and here root 4 into root 5 means 4 into 5, that is root 20. Then 49 is greater than 20. Therefore here root 49 is greater than root 20. Therefore here 7 is greater than 2 root 5. Then we can compare between surds as well as we can compare the numbers which is rational numbers and surds. Then we will solve few examples which is based on, that is the few operations which is takes place on the surds, that is the different types of operations takes place on surds, and that is of addition of surd as well as subtraction of surd. Subtraction of surd also takes place. Multiplication of surd, and division of surd. Division of surds can be takes place. First of all, we are going to solve few examples of addition of surds. Then see here, taking one of the example of that is the example 7 root 3 plus here 29 root 3. See here the surds which is given in the simplest form, and here the surd which is given in the simplest form of which order is also same. See here order, that means here order is 2, and here radicand, that is A is the radicand which is also same, that is 3. That means these are the like terms or like surds or similar surds. We can do only addition of similar surds, and we can't do the addition of dislike surds or dissimilar surds. Therefore, first of all, those surds, if it is given in mixed form, then we have to convert those surds into simplest form, and we have to convert those surds into the like surds. Then we can do the addition or subtraction between similar surds only. Then here, how to do the addition of those surds? See here, 7 plus 29 and root 3 is taken as a common, and therefore 7 plus 29, that is 36 root 3. That means we can write that surd in simplest form, or we can convert this surd into mixed form also. That is about the addition of surds. Then taking few examples from practice set, you may do the practice of solving the examples which is based on addition of surd as well as subtraction of surd. One more example, that is I am going to discuss with you, that is of subtraction of surds. Then see here, 9 root 5 minus 2 root 5. See here, those are also similar surds. Therefore, we can do the subtraction between those similar surds. Therefore, here the same process is carried out like in the addition of surd, that is 9 minus 2, and here root 5 is taken as common, and therefore here 9 minus 2, that is 7 root 5. That is about the addition and subtraction of the surds. Then we can do the addition, we can do the multiplication and division of surds also. Then we will solve few examples which is related with the multiplication and division of surd. Then third one, that is multiplication of examples which is based on multiplication of surd. See here, multiplication of surd. Then taking one of the example of it, that is 3 root 5 into root 7. See here, 3 root 5 and root 7 are not the similar surds, but we can do the multiplication of similar surds as well as dislike surds also. Then see here, 3 root 5 into root 7. Then taking care of, then one care is taken here, that is only order of that surd should be same. See here, n is equals to 2 as well as here n is equals to 2. But radicands are not same. but we can do the multiplication of those surds of which order is same. That means if root of 5 into cube root of 7 is there, then we can't multiply those surds. We can multiply those surds, but we have to do the same orders of both surds. Then we will solve the examples of multiplication of those type of surds later. Then first of all, see here, we have to take care about that order of those surds should be same. Therefore, here orders are also same. Therefore, we can do the multiplication of those, that is 3 into root 5 into root 7. Then 3 into root 5 into 7. Therefore, 3 into root 5 into 7, that is 35. That means we can write 3 root 35, or we can convert it into mixed result, that is 3 means root 9 into root 35, and therefore here root 9 into 35, that means here 9 5s are 45, carry 4, 9 3s are 27 plus 4, that is 31, root 315. Or we can write this into their simplest form also. Then see here, one more example of multiplication is there, that is 2 root 9, 2 root 5 into 5 root, that is 10. Then see here, one of the example of multiplication is given here, 2 root 5 into 5 root 10. Then we have to do the multiplication of those, that is 2 into root 5 into, that is 5 into root 10. Therefore, here 2 into 5, 2 into 5 into root 5 into root 10. Therefore, see here 2 into 5, that is 10 into 5 root 5 into 10. Therefore, 10 into root 50. Then we can write this in the simplest form also. That means here 10 into, that is 50 means 25 into 2. Therefore, here 10 into 5 root 2. Therefore, 10 into 5, that is 50 root 2. Or the same answer we can write in the mixed form also. Then 10 means root 100 into root 50. Therefore, see here, root 100 into 50, that is root 5000. Then we can write the answer of that surd in mixed form as well as in simplest form also. Then one more operation we can takes place on the surd, that is division of surds. Taking one of the example of division of surd. Then for example, see here, root 125 divided by root 50. See here, division of only those surds can be takes place of which order is same. See here, order of those surd is 2, that is same. Therefore, we can do the division of those, that is root 125 divided by 50. That means the same surd can be written like this, root 125 upon 15. Therefore, see here 125 and 50 both are divisible by 25. Therefore, we can write here 5 into 25 means 125 upon 2 into 25, that is 50. Therefore, cancelling 25 upon 25, that is we get root 5 upon 2. That means we can write this like root 5 upon root 2. Then see here one more concept which is related with the surd, that is rationalization of surd. See here, rationalization of surd means here root 5 is irrational number upon root 2 is also irrational number. Then here numerator is also irrational number as well as denominator is also irrational number. Then there is method or formality to convert the denominator into rational form. If denominator is irrational number, then we have to convert that irrational number into its rational form without changing the value. Then to convert that root 2 into rational, therefore we have to multiply those number by root 2 as well as divided by root 2 by same number. We can multiply as well as divided by that same number. Then the value of this root 5 upon root 2 cannot be changes. Therefore, see here root 5 into root 2 upon root 2 into root 2. That means here root 5 into root 2, root 10 upon root 2 into root 2, that is root 4. Therefore, see here root 10 upon root 4, that is 2. Then see here root 5 upon root 2, that means it is a root 10 upon 2. That means this surd or denominator of that surd, it is converted into rational number, and that process is called as rationalize the denominator of given surd. Then that process of rationalizing the surd, that is rationalizing the denominator of given surd, that will be discussed in next lecture. Then you may solve the examples from practice set 2.3, which is based on the degree of surd, then comparison between surd, as well as addition, subtraction, multiplication and division of surd. And we can also identify the like terms or similar surds as well as dissimilar surds. And we can also convert the surds into their simplest form, or the simplest form of surd can be converted into their mixed form. The examples which is based on those all concepts you have to solve from practice set 2.3. Thank you.